invoke her blessings to all of us. And there's so much of celebration is around, and I was finding it really difficult to find time to announce this launch of this very much awaited module, the adolescent vaccination module. Actually, it all started when myself and Dr. C.P. Bansal sir were thinking that we should have something special this year in the field of vaccination. And adolescent vaccinations, we all know, needs a lot of boosting up. And we all are aware as pediatricians that even after the childhood vaccination, especially after 1 year, even at the booster dose of 5 years, there's a lot of dropout rate. And nobody talks about the adolescent vaccinations, and we very few talk. And there is a need for the adolescent health chapter to really do advocacy around adolescent vaccination. So this year, since this is a silver jubilee year, and apart from all other initiatives, like we have taken up the boy child module, the youth wellness module, the adolescent counseling as a workshop, as a certificate course. We also did the parenting, empowering the parents. So we are all there to empower parents, empower youth, and we thought that we should also get something out for the vaccinations, which most of the pediatricians would be interested. So we all know that we all are doing a lot of vaccinations as a prevent to promote to strategy. And this is really appreciated both by the WHO, all global organizations, the UNICEF and the and also is coming in a big way. And we have to be timely in alignment with the global call. So we thought of bringing out this one shot ahead, special module on adolescent vaccination. So all the today the TOTs are nominated by members of the group, special group who have been creating the adolescent vaccination module and all the OB and EB. So this we had actually thought of a physical TOT, but due to funding issues, we were all looking for a physical either in Hyderabad or in Delhi or Mumbai, but it was getting delayed. So we have thought we'll go virtual this time for the TOT, and definitely we'll have a review meeting in the month of November, which will be arranged in Hyderabad, since the Bharat Biotech has come forward and they have given this venue for us. So we can have a review meeting of all the TOTs there in the month of November. So
It is large.
the idea is to cascade this module down to every pediatrician, and there shall be a zonal and the city level meetings also later on. And we are very proud that
Control.
Vivek, can you please mute? We are very proud that this module is under the guidance of Dr. C.P. Bansal sir and Dr. Kasi sir, who's an authority. We all know him very very well. And the way he speaks about this vaccinations in any of his programs are a big hit. In all the even in the pedicons, any workshops. So this module has this structure. The patrons are Dr. Vasant Kalatkar, Dr. Neelam Mohan, and advisors are Dr. M.K. Sinaya, Dr. Swati Bhave, Dr. Kamath sir, Dr. Indrashekhar Rao, Dr. Sanjay sir, and the national chairperson myself, the joint national chairperson Dr. Sushma Desai and Dr. Geeta Patil, who are my other chairpersons, the past and the future. The national convener Dr. C.P. Bansal sir, national co-convener Dr. Suren Nath, national coordinator Dr. Vineet Saxena sir, national coordinator Dr. Sanjay Marathe for this module, and the scientific chairperson is Dr. Srinivas Kasi sir and Dr. Vipin Vashisht. And the writing committee is Dr. Sanjay Marathe, Dr. Ganesh Kulkarni, Dr. Arun Vadwa, Dr. Shashi Kant Dheer, Dr. Sanjay Verma, Dr. Kripa Sindhu Chatterjee, Dr. Sunil Agarwala, Dr. Sumita Nayak, Dr. Sagar Kulkarni, and the EB in charge, Dr. Chandra Mohan. You also have Dr. Chetan Trivedi and Dr. Bhaskar Shinoy giving their contribution and also as reviewers. And apart from these two names, we have Dr. Bansal sir, who has reviewed this module, and Dr. Kasi sir has given a lot of contribution to this module. Without him, it would have been not possible for us all to come together. He was time to time guiding us. Dr. Vipin Vashisht sir, we thank you for reviewing this model, Dr. Surenath ji and Dr. Marathe. Now, I request our chief guest of honors and the chief guest to inaugurate the module, I requested our past president, Dr. Raju Shah, Dr. Nitin Shah, and of course, Dr. Atanu Bhadra, who will be giving his blessings on behalf of the Central IP leadership. I especially welcome all three of you, sir. And over to Dr. Raju Shah, sir, for his inaugural launching address. Sir.
Hello, good evening, everyone. Dr. Himabindu Singh, Dr. C.P. Bansal, Dr. Kashi, Dr. Nitin, Atanu Bhadra, and other dignitaries. It's really a great pleasure launching this adolescent vaccination module. We all know that probably India is one country where we have almost 22 million percentage-wise, almost 14% of our population is adolescent. And still, if you look at the vaccine coverage of adolescent, is probably less than 5%. So there are multiple reasons why the vaccination coverage is not increasing. And the most important is the lack of advocacy and the information to the parents. If you look at the recommended vaccine on behalf of IAP also, then there are very limited and the availability is also an issue, because all the vaccines which are recommended are has to be taken at a private level, and parents have to spend money. So these are the issues. We in IAP, when we had prepared our IAP modules, almost 7-8 different modules came till now in IAP. In each and every module, adolescent vaccination was part of those modules. But I'm happy that now it's a separate module which is coming up, and probably that will definitely add to the more information, and more and more pediatricians will be recommending and pushing for the vaccination. I inaugurate this program, and I wish all the best that it will be most successful, and almost all the branches of IAP will have one such session. Thank you for inviting me and making me part of this very important launch of the module. Thank you. Thank you, everyone.
Thank you, Raju Shah, sir. Thank you so much. Now, I think Dr. Nitin Shah will be joining us shortly. I request Dr. Atanu Bhadra, our treasurer, and I think the only representative right now from Central IP leadership. We also invited all the vice presidents. Arya sir, I'm on the mobile. Kindly see if they're there. We can invite them. Over to you, Dr. Atanu Bhadra, for your blessing.
Yeah, thank you, Dr. Himabindu ma'am.
Ramesh Bajania is there.
Yeah, okay.
Yeah, so this has been a long initiative. In fact, I have heard many times that CP Bansal are presenting on adolescent vaccination, and I think the initiative that he took through the years, it has been molded, and the vaccine experts, including the vaccine Doyen of India, Dr. Kasi sir is there, with all his teammates, Sanjay Maratha, Sunil Marathe, Sunil Agarwala, Kripa Sindhu, and in fact today we have a solid recommendation and document to bank on. And with under 5 vaccination already gone out of our hands, I think the future bread and butter would be the adolescent vaccination. So that is the financial part of where all pediatricians should be involved. And I thank the adolescent chapter to have taken this initiative to put it. Let us circulate it everywhere and see that everyone gets it. Is initiated to start adolescent vaccination in their clinics, and let us take it up with the government, I think, at that level, so that there can be a partnership with the government level. So yes, now Dr. Ganesh Kulkarni, another vaccine expert, has joined. So it's a real platform. Thank you for inviting me, and a great initiative on behalf of the adolescent chapter. Congratulations to all the adolescent chapter members, including myself, because I am a member of this chapter also. Thank you. Thank you.
Thank you, Dr. Tanu, for your blessings. Now I request all the vice presidents, Senior Most Vice President Dr. Bajania, sir. Sir, over to you for your address.
Thank you, Himabindu ma'am, for this opportunity. In fact, I must first of all tell you that of late adolescent branch has developed into a separate fraternity where many youngsters they are opting for it. But you have shown a new direction in form of adolescent vaccination. So if someone starts exclusive adolescent vaccination clinic, then also I can say that he or she can earn the bread butter. So that was on a lighter side. So thank you so much for this initiative, and I'm very sure because most of the time what happens that the children once they cross 5 years of age, we lose them as far as vaccination is concerned. But now with the advent of influenza and all other vaccines, we at least can track them, and simultaneously during those visits we can also follow them up for other morbidities like autism, etc. So the adolescent vaccination chart, I would recommend and request AHA chapter to come out with it so that everyone can tangle in their waiting room so that the parents are sensitized. Because if you ask 100 parents, then hardly uh, one or two they know about the vaccination of adolescents. Most of the time when their children, son or daughter, they go abroad for study, then they visit you for vaccination. Otherwise, those who don't go, you lose practically them. So once again, I congratulate you for this wonderful initiative and thank you so much for this initiative.
Thank you, Bajania sir. I think all the presidents are abroad. So thank you. You're representing the Central IP leadership, sir. Thank you for coming over. Dr. Preeti Galgali is here, Dr. Prashant, and anybody is here. Preeti, over to you, Preeti, as Vice President.
Thank you so much, Dr. Hima Bindu Singh, and congratulations on this wonderful initiative. I think that adolescent vaccination is going to be a game changer in adolescent health. And with HPV vaccine being there right at the brink of being adopted by the National Immunization Schedule, I think this would allow adolescents to enter the health system, which is so very important because, as we know, adolescents are hesitant to come into the health system. And with the dengue vaccine also there on the annual, I think there are lots of new vaccines for adolescents. And I wish the program the very, very best, and always remembering to partner with the government because that is going to be really important as we move forward. Thank you.
Thank you, Dr. Preeti. Now, sir, can we invite Dr. Kasi sir, CP Bansal sir, are the backbone or I should say, the main leads for this program. Kasi sir, CP Bansal sir, over to both of you.
Thank you, Dr. Hima Bindu. I have been involved with quite a few IAP vaccinology modules. We have had adolescent vaccination, but 5 slides, 6 slides, and that was the end of it. I'm very glad that now there's an exclusive adolescent vaccination schedule, something that is a crying need, and I'm glad that void is being filled up with this particular module. And as was stated earlier, somehow the thrust has always been on under 5 immunization. But now with under 5 immunization reaching figures of over 90%, it's now time to focus our attention on adolescents. And I'm very happy that this module is the first step in that particular direction. Thank you all.
Thank you, Kasi sir. You have been our mentor guide for this whole module. And thank you. It's a dream for all of us. And we have made it under your leadership. Sir, Dr. CP Bansal, sir, it was sir's concept actually, and then we have brought it to this level. Our past chairperson and past IAP president too. Over to you, sir, for your blessings.
Thank you so much, Dr. Emma Bindu. In fact, let me first extend my very sincere gratitude and respectful regards to Dr. Raju Shah, sir, the past national president, Dr. Atanu, the national treasurer, and a dynamic treasurer, I'll say, ready to take newer role in Pedicon with football already at his back. All the vice presidents, Dr. Ramesh, Dr. Preeti, the national chairperson, immediate past national chairperson, Dr. Geeta Patil Madam, and all the office bearers of AHA. In fact, it is a historical day in history of Adolescent Health Academy since many years. I do remember when we introduced the first module of adolescent health way back in 2007 for adolescent care in office practice. At that time, also in that module, we had a chapter of adolescent immunization. And we had been focusing on adolescent immunization. And in fact, we have been very strongly putting it forward. But it was only last year during Dr. Geeta Patil's tenure that we could come out with an adolescent immunization card. And that too, that was again ratified by none other than our Dr. Kasi, Dr. Vipin Vasist, and other members of immunization committee. The major breakthrough this year happened when the committee members of IAP-COI agreed to support us for this module, and that too, the doyen of immunization and the chair of immunization for so many years, Dr. Kasi sir, agreed to take the lead and guide us very actively through this module. Dr. Sanjay Marathe and all the writing team members, they have agreed. And I completely agree with Atanu's comment that it is not only the need of the day, but this will also be a future of adolescent immunization will be a future in our office practice. It is really pathetic to note that we are the largest vaccine manufacturers in the world, while rightly said by Kasi sir, it is less than 5% adolescent immunization. We have so many cold chain points, almost 29,000 cold chain points, but everything being focused to under 5 immunization. I am sure, Dr. Preeti, that once this module goes through, the government will definitely approach us, and we will definitely be looking forward for cooperation and collaboration with Government of India, with UNICEF, with WHO, and Dr. Hema Bindu, I am sure she will leave no stone unturned to see to it that this collaboration takes place. I warmly welcome and congratulate all the participants of today's TOT and assure you, dear friends, that this will be one of the most successful modules of not only AHA but of Indian Academy of Pediatrics, because it has determination of Adolescent Health Academy and is science backed up completely by IAP-COI. So hearty congratulations to you all, and thank you so much.
Thank you, sir. Thank you so much for your guidance. And now I request Dr. Vineet sir, Vineet Saxena sir, Dr. Vipin Vashish sir, coordinators of this program, Dr. Surendra ji. Yeah, he's there. Dr. Surendra ji. I saw him. Dr. Sanjay sir, Dr. Indrashekar Rao sir, Dr. Geeta Patil, madam,
Okay.
master
Thank you.
person.
Thank you, Dr. Himabindu, madam, for giving me opportunity. It's a need of the day, as it is talked that adolescent immunization has to be uh, made awareness. And Bansal sir was telling for so many years, and he was the first one putting in our head that this is the essential part of our last module also, what was done under his leadership. And now with his ideas and leadership with Dr. Kasi sir, Sagar Kulkarni, then Sanjay Marathe sir, Sunil Agarwala, and Vipin Vasisht, and many are there who have contributed. I also was in the group, and the way it was going on, uh, it's going to be useful to the everyone, and it is required to be taken to all the cities, and it has to be everybody has to be aware of this schedule. Last year we had a Kishore Mitra card that was also done under leadership of Kasi sir, and that card is being used by many. And that card was a very precise way it was done, with a little messages to the adolescents. So this is a very important module, which as already everyone is telling that this is going to be useful for everyone. Thank you very much, and the response will be really great. Thank you, Dr. Himabindu Madam, to take it forward in spite of so many challenges you faced. Thank you.
Thank you, Geeta ji. I think we had a superb team, a superb leader, superb scientific lead. We had the expertise is so much in this group. I'm sure this vaccine module will be taken well among our pediatricians, and we should see great success. And we, as already said, our seniors said we should try to reach out to the government and collaborate with them. So we'll, Docent Health Academy is committed to do this, and we'll take the lead in this matter. Now over to our Sanjay Marathi. Please conduct the rest. I think you can introduce the speakers. If you have left out anybody here, seniors, please let me know. I think we can go to the first session. Dr. Sanjay, our digital in charge, I would like to just mention is Dr. Ganesh Kulkarni. He has done a wonderful job in formatting all our slides. We had number of sessions where we had reviewed all the slides one by one. We had so many live sessions, and at the end we had requested Dr. Ganesh to sort of put it everything together. Thank you, Ganesh ji. And in spite of your busy schedule, you have done that. And there's a pre-test is already posted in the TOT group. I request all the members to kindly take the pre-test. There's also a post-test tomorrow. So today we are starting a little late because we wanted Dr. Kasi sir to be with us, and he requested us. And I'm sorry for those members who are not able to attend. And I'm sure this Navratri, all of us are busy and all the families are busy. But during this festival season, very auspicious days, let us launch this module, and we can see more sessions later when we are at leisure. Tomorrow's sessions will continue at 2 o'clock, and most of you will be attending. And the link of today's recorded session will also be posted for those who could not attend. So over to you, Dr. Sanjay Marathi, to our coordinator for this module, to do the rest of the proceedings. I acknowledge the presence of our Dr. Sanjay, Dr. R.N. Sharma ji. Is Sushma Desai present here, our future chairperson-elect, for our message? If
She's
she's
not
there,
there. She will join, she has told.
Yeah. So we shall move ahead. Thank you, Raju Shah sir and others for giving your inaugural address and for launching our module. Now over to Dr. Sanjay ji, who's been our coordinator for this module. Over to you. Unmute
करें सर. संजय सर अनम्यूट करें.
Thank you for the opportunity, ma'am, for this wonderful module. All our writing committee has worked really very hard under the guidance of Dr. Kasi sir, who is our guiding force, who is our helper, CD4 cell also, and he is an advisor for us. Thank you, Dr. C.P. Bansal sir and Dr. Vashisht for the guidance from time to time. The writing committee, we have got excellent speakers. They are known faculties and they are speakers for the national conferences. Dr. Vadha sir, Dr. Kasi sir, Dr. Sumita Naik ma'am, Dr. Kripa Sindhu, Dr. Sanjay Verma, Dr. Sunil Agarwala, Dr. Ganesh, and Dr. Sagar, and myself. For the convenience, we have divided this module into two because of the short of time. Today we will have 4 lectures, and tomorrow we will have 4 to 5 lectures, and that is how we are going to complete this module. The question answer sessions will be there for 5 to 10 minutes after each talk. And first we'll finish one topic, then we'll have a question answer for 5 minutes, then we'll go ahead with the second. The first talk will be by Dr. Sanjay Verma. I request him, as we are running short of the time, I request him to start with his first talk. And I think time allotted is 30 minutes.
Dr. Sanjay Verma ji is from our PGI Chandigarh, Actually, I just happened to go and meet him recently. He's one of our core members of this vaccination module. Dr. Sanjay Verma ji has many interests, apart from especially in research, and he has been part of many more projects. With him, I did even the rubella CRS model thing in the research. I'm sure he has a lot of publications to his credit. A very short introduction to you. Over to you, Dr. Sanjay Verma.
Thank
For
you,
his
ma'am.
first topic.
Am I audible?
Yes,
It's
yes,
also clear. Yes.
yes.
I
Voice
think we
is
have
clear.
Dr. Uh, please invite the
Rajesh.
chairpersons also, na? Dr. Sanjay Marathi.
Actually,
As
I
per the
am in the
program
hospital,
schedule.
sir.
Acha, who was the chairperson?
डॉक्टर राजू शाह सर हैं
And Vineet
एंड
Saxena
डॉक्टर
ji.
विनीत सक्सेना सर
अच्छा अच्छा राजू सर है ना
हाँ, राजू
डॉक्टर
साहब
राजू
नहीं।
शाह इनके
Yes,
बारे
sir.
में थोड़ा सा ही इज द
Sir.
पायोनियर इन द फील्ड ऑफ न्यूनेटोलॉजी इज ए मोस्ट रेपुटेड एंड सीनियर मोस्ट पीडियाट्रिशियन ऑफ अहमदाबाद established private sector in NICU and PICU ventilator. Welcome, Dr. Raju sir.
No, everybody knows sir as a past president of IMP.
Sir,
And thank you, sir, for taking your time on this festival season. Thank you, sir, for chairing the session too.
Yeah.
Request Dr. Sanjay Gupta, to start the session.
Okay, thank you, ma'am, for this wonderful opportunity to interact with so many wonderful people here. So you can consider me the Abhishek Sharma for today's match. Tomorrow we are going to have a match. So first speaker for this. So I have been asked to give the first talk, and I have to talk about why we need this adolescent vaccination and do we really have a disease burden. So something about this I will talk about. So okay, so this is what we see. Why do adolescents need vaccination? So that is the first question which comes to our mind. You know, that childhood vaccination everybody knows, but we do not often talk about this. But the reasons why we need adolescent vaccination is number one, do we have a burden of VPDs in adolescents? So that you see that we do have a burden of diseases, vaccine preventable disease in adolescents, and I will be talking more about it in the coming slides. And you must have seen cases of varicella in adolescents. A lot of patients come with mumps, come with so many burden is there. Then another issue of waning immunity from childhood vaccine. That is becoming more important these days when we are increasing the childhood vaccination, we are covering the maximum children, then this waning immunity issue coming up. And you know that diphtheria, pertussis, these are the diseases which are occurring these days in adolescents. Then do we have an adolescent specific vaccine? Yes, we have. HPV is there, Tdap is there. So we have certain vaccines which are given in this period. Then we have a group of comorbidities in adolescents. We need to address the issues with them, like we have patients with asthma, we have patients with diabetes, immunodeficiencies. So these also people in adolescent need special vaccination needs. And overall, this adolescents, like we said earlier, it's a significant population. Around 20% of population we say is this adolescents. So the immunity of this adolescent group is going to contribute significantly to the community immunity as well. What we call herd effect. So that means you need to vaccinate all the people in that group. So herd immunity will help in those who did not take vaccine because of many reasons, like many patients cannot take because of their illnesses or because of other reasons. So they will also be protected if we build community immunity. And overall, this will going to contribute significantly to the public health as well. And this adolescence is not the only period. This preventing illness in this group will also protect long-term health issues. So it is more of a investment to prevent diseases in the later age group. Economic issues are there, economic benefits are there for the parents, for the government, and for the children as such, for the adolescents as such. The developmental benefits means they could attend regular classes, and the economic productivity will also come, and developmentally they will be better if they get free of diseases. I think there are various reasons why we need to consider vaccination for adolescents. And this, if you want me in numbers, means do we have, how much is the burden of communicable diseases or infectious diseases which affect adolescents? So this is given in this chart, like mortality, how much deaths is it cause, and this is more of an morbidity. So morbidity they measure in terms of these terminologies called YLD. YLD means years lived with disability. These are the standard terms. And this is one more thing called DALY. DALY means disability adjusted life years. So disability adjusted life years includes the years lost because of deaths and also because of morbidity. So this is a much better indicator to say that how much is the burden. So you can clearly see that mortality because of communicable diseases or infectious diseases contributes something around 35 to 45% or even up to 50% of your total burden. So significant amount of adolescents die because of infectious disease, and large amount of them could be prevented. And this year, this what I said, the years lived with disability. So what it says is that out of all years lived with disability, 15%, 17% is because of infectious diseases. So that is a good number. And daily, like I said, it is the combination of deaths, years lost because of death, and years lost because of disability, the combination of that. And that is coming out 26, 27, or 20 to 20. So if I say that overall in adolescents, around 100, every 100 years lost, 25% or 26% is contributed by these infectious diseases or vaccine preventable disease. Overall, what I'm saying to say that at least 25% of morbidity and mortality can be prevented probably by using appropriate vaccination in adolescents, which is happening these days. So that is the concluding message from this slide. So you can see that why adolescents to be considered as special groups. You see here how where the adolescence lies. There's something here though. So it is corresponding, it's a big chunk is adolescence. So around you can say at least 20% of our population is adolescents. And so that will be something around 25 crores of population is adolescent. That's a very big number. And of them, 25% of morbidity and mortality is because of infectious diseases, which largely can be prevented. Then it makes a sense to talk about this adolescent vaccination. And adolescents are equally vulnerable to number of diseases. Their complications are, most of it are vaccine preventable diseases, like I said before. And with good EPI coverage, there is an epidemiological cyst of childhood diseases to older age. That is another issue which is coming up. And the WHO says that in 2016, an excess of 1.1 million adolescents aged 10 to 11 years died, many due to preventable causes. So a large amount of adolescents are dying or getting disease because of these things which can be prevented. So that is an important thing to talk about. Why should adolescents be considered as special group for vaccination? One group I said is waning immunity of childhood vaccines like tetanus, diphtheria, pertussis. Another is those vaccines which are especially given in this age like Tdap and HPV. And then adolescent with comorbid condition, that is another issue which we need to target, special conditions. So this is very commonly talked about term these days, a life course approach. I was recently in an adult ID conference and they were also talking about life course approach to immunization. So what does it mean? It means that immunization is not limited to children. We need to talk about immunization about every group. We need to talk about immunization in adolescent, immunization in adults, immunization in elderly, immunization in pregnant women, because everything is important and they have things which immunization can prevent. So we need to have a life course approach to immunization states that person should receive all recommended vaccine doses along their life course to get the maximum benefit of preventing vaccine preventable diseases. at different ages, across generations, and within these communities. And we know that how much we have adolescent immunization schedules these days. Till now, we had a very minimalistic adolescent immunization schedule. So that is the truth. So do we have some numbers to say that we actually had what I said? Do we have some studies to quote whether we have a significant burden of VPD, especially from India in adolescents? So this is about pertussis. So this was a study which was conducted in many Asian countries. You can see that this China, India, all these countries are there. And this is a multinational sero survey where they looked for the different antibodies against this, how much is our protected, people are protected. So in India, you can see this is the population and they look for pertussis, anti-pertussis IgG, more than 62.5. Actually, in pertussis, it is very difficult to have a surrogate protection. So to say that that much is considered protection, immunity is there or not. But whatever it says is that the number, even more than 16.2, was very less, 6.1% only. That also denotes a recent pertussis infection. So the number overall was very less. So very less people were having protective antibodies against pertussis in all of these countries. And this was very surprising. And you see this comes more than 1 crore, you estimate the pertussis cases. And if you see the pertussis prevalence from this estimated burden, they said around 6,000 pertussis cases every 1 lakh of population. So that is what the burden which was estimated. And you can see this chart here that the number in the adolescent age group is quite significant because of pertussis. So a lot of people are having pertussis diseases, these things. So to conclude from this slide, there is significant circulation of B pertussis among Asian children and adolescents, with 1 in 20 having serological evidence of recent infection regardless of vaccination background. So the apparent burden of pertussis may not be that much, but the main thing is they are having disease which is spreading to other children. So some milder disease they have, and that is a source of infection for the others, like especially the younger children, the infants. Pertussis scenario is almost similar what I said about diphtheria. And you can see that the India contributes to 92% of cases of pertussis around the world. So significant burden of pertussis we have in India. And if you see in different states, then you can see that over 10 years of age, the burden is quite significant of diphtheria. And 2,400 school children aged 6 to 17 years studying in various government schools in Hyderabad, only 56% has protective titers against IgG. This is level of more than 1 IU per ml. So this the similar study we have conducted at Chandigarh also, and that is also a similar kind of a thing is coming up. So a large burden of population are having subclinical immunity, which is they make them susceptible to develop diphtheria. So that is also an issue. So you can see a lot of reports are there. 124 lab confirmed diphtheria cases in Telangana, and then this age range was including adolescents, and the highest annual incidence was there in 10 to 14 years, and that was, you see, then Kerala there are reports of this diphtheria in adolescents and adults, and North Maharashtra also there are reports of this thing. And this is probably the largest study we have about zero prevalence by the ICMR with Dr. Murhekar from NIV Pune. They did this study in 2017-18, and they said around 40% of this 25 to 40% of the children were susceptible to having protection against diphtheria. So around 40 to 50% of them were susceptible to diphtheria. They don't have enough immunity. Similar thing were reported from northern Karnataka. There are cases of diphtheria there also. So I can imagine that a large number of these patients will be unimmunized. But how much is the decay of antibodies over the period is contributing is difficult to say, but definitely that will also be contributing with the progressing age. Tetanus also have some cases, and you can see that even adults had a lot of tetanus. 255 healthy individuals and adults in Delhi were reported, and a large amount of them were susceptible to tetanus in a sero survey. School children in Hyderabad, 64% were immune, so around 40%, 35 to 40% were having susceptible to tetanus. So here comes the role of this Tdap vaccination in adolescents. Measles, mumps, rubella, varicella, also they screened for their how much of them were susceptible. So measles around 10%, mumps around 32%, rubella around 16%, and varicella around 25-26%. So large amount of our adolescents and adults may be susceptible to mumps and varicella. That is the reason we see so much of mumps and varicella cases in our population. Involvement of adolescents has been reported in mumps outbreak in Rajasthan and Orissa, and we had a very bad outbreak last year in northern India, also including Chandigarh. And rubella also has around 10 to 15% susceptibility is still there. HPV, the issues are important. We have around 119 million adolescent female population which are at risk of cervical cancer. In 2026, this figure says that around 1 lakh women were diagnosed, more than 1 lakh were diagnosed with cervical cancer, around 77,000 died. So it's more than that. So they died because of the disease. So we have a good burden of cervical cancer in women in India also. And you can say that incidence of cervical HPV 16 and 18 infection at a given time in women in general population was estimated to be 5%, and about 4% were of this reproductive age group women are going for routine pap smear testing. So we are lacking in immunization, the primary prevention, and we are lacking in secondary prevention, means early diagnosis also. We need to work on both areas if we want to protect this HPV. Typhoid, I think nobody will disagree with me that we have a good amount of burden of typhoid in adolescents also. Possibly the second largest group after children is adolescents which have typhoid. And these are the studies to quote with which say that the second group is 5 to 15 years, 5 to 14 years with a significant burden of typhoid. Streptococcus pneumoniae, this study was in 1999 where this systematic review and meta-analysis were done before this PCV was coming to our national immunization program. And they say that the total burden of community-acquired pneumonia in Indian adolescents and adults because of streptococcus pneumonia is around 19%, 20%. So that was a significant burden before, but we need to check how is the status now after at least 2 years of vaccination in the national program. So whatever I have said is thus that adolescent immunization is important. So which are the major groups where we are going to talk about today in subsequent lectures? So routine vaccination. We know that Tdap and HPV are the two vaccines which we need to understand more, means how we can ensure the vaccination of that. Then catch-up vaccination, second group. That is typhoid, hepatitis B, hepatitis A, MMR, and varicella. These are the vaccines which are given in childhood, but we need to ensure that they have given in the past. Otherwise, we need to give them. And then we need to also consider these vaccines to be offered in special circumstances, like in travel, meningococcal conjugate vaccine, JE vaccines, yellow fever vaccines. And in animal bite cases, rabies, and in immunocompromised patients, PCV, influenza, and MCV, meningococcal conjugate vaccine. I think these are the vaccines we are going to talk about in details in the subsequent presentations. I think we can, I can stop here and over to you if there are any questions.
I think Sanjay has included almost everything about the available data on epidemiology of all these important vaccine preventable diseases. And that already tells us that what is the need of this vaccination program and the need of this module, so as we can now aware our own members and increase the vaccination coverage. Thank you, Sanjay.
Thank you, sir.
Thank you, sir. Marathi sir is busy. After this wonderful talk by Dr. Sanjay Verma sir, I think everyone is very clear, crystal clear in his mind that need for vaccination in adolescents is so important. And perhaps The myth that vaccines are only for the tiny babies is the second greatest myth after vaccines causes autism is perhaps the top till today. What sir has explained as life course immunization, and through that, we need to vaccinate all babies from day 1 till the geriatric age group. Thank you, sir, for establishing a wonderful context of need for vaccination in adolescents. So now I request Dr. Sagar Kulkarni for his next talk. Without understanding the basic vaccinology and the principles of vaccination, I think it is futile to learn about other vaccines. And who else other than Sagar can explain these basic concepts to all of us in his wonderful way and wonderful style. So I request Dr. Sagar Kulkarni and to chair this session. I request Dr. Geeta Patil ma'am and Dr. Prajapati sir. Dr. Geeta Patil ma'am. Ma'am, thank you for chairing this particular session. We all know your contribution in the field of adolescent medicine, and you have always been a guiding light to all of us. And thank you for being here today to chair this particular session. And I request Dr. Prajapati sir. He is the teacher of teachers. He has always been there for us. Whatever pediatrics that we have learned from our childhood, perhaps he is the backbone to it. So I request Dr. Prajapati sir to please chair this session along with Dr. Geeta Patil ma'am. Over to you, Sagar Kulkarni.
The questions can be posted in the chat box. Dr. Ganesh, we can attend to that.
I think Dr. Prajapati sir is not there. I request Dr. Sagar Kulkarni sir to share your
I think we
slide.
can take all the questions in the last session.
Yeah,
Can
yeah,
we?
yeah.
It will be better.
The flow.
Yeah. So we'll finish all the lectures and then we'll take all the questions in the last and have a wonderful discussion amongst each other.
Okay, okay.
Dr. Sagar, please go ahead.
I think we can request Sagar Kulkarni sir to go ahead because without
Yes.
wasting much time.
Thank you very much. So the topic which has been given to me is basic vaccinology. Someone might think that this is a module only for adolescent and what are we doing with this topic? But understand me well. If you understand the basics, all the questions in your mind are going to be very much clear. And your basic principles, if they are strong, it will be at ease. You will be vaccinating these adolescents. So what is our aim? Our aim is to protect an individual. Our aim is to protect the community. Our aim is to protect those who are at highest risk. What are our aims? We want to control the disease. So what is the control? Control is reduction in the occurrence of a disease to a locally acceptable level. So whenever I speak of this term control, I'm actually talking about a terminology which is there for a locally acceptable level. Second thing, we want to eliminate this disease. What is elimination? It is the reduction in the case transmission to a predetermined very low level. So the level has already been decided. So that is called as elimination. And we all know the tetanus neonatal and maternal elimination program, which is going on very well in our country. The third is eradication. What is eradication? It is defined as termination of all transmission of infection by extermination of the infectious agent. So once you achieve it, you can stop all the interventions and control measures once you have achieved the eradication. So is there any disease in this world which we have eradicated? Yes, at least one we have eradicated, that is smallpox. But the question is it extinct? So what is extinction? It implies that the specific infectious agent no longer exists in nature or in lab, and we know that smallpox is still there in lab. So it has been eradicated, but not yet extinct. To understand this slide, let us go to the basics. So how is immunity divided? First is the innate immunity, which is made up of, let us say, the pH, the epithelial cells, then our macrophages, basophils, and so on. And there is an adaptive immunity. Adaptive immunity again is of two types, the B cell immunity and T cell immunity. B cell immunity, they will produce antibodies. Antibodies will be responsible for clearance of mainly extracellular organisms, and How antibodies will act? They will act by opsonization, they will act by neutralization, or they will act by complement mediated things. What about T cell? T cells, the CD8 cell, they will act via cytotoxicity by killer cells, and the CD4 cells, which itself will help in production of antibodies by B cells. So we say that this innate immunity, this B cell immunity, this T cell immunity, they are different, but actually there is an interplay between all of them, and all of them help us to defend the body. This chart, which is shown here, it has been simplified. Let us simplify it more. So whenever an antigen is given, this antigen presenting cells, that is the dendritic cells or macrophages or B cells, they take it, they break it into small peptides, and they present it. So the MSC1 class basically deals with viral. It is going to activate the CD8 cells, will help in cytotoxicity and also through cytotoxic mediators. MSC2 basically will work with CD4 cells. It will act via the T helper cells and the memory or the effector cells. So understand, whenever there is an infection in the body, it activates the B cells. There are millions of B cells, but they are specific. So these B cells, they produce plasma cells. Plasma cells are going to produce IgM antibodies, mainly less of IgG. The IgM antibodies will remain there in the body for some time. They will go down and you will get an immunity of, let us say, 2 or 3 years. So this similar pattern, this occurs in what we call as an extra follicular reaction in a lymph node. So let us say if you have given a polysaccharide vaccine, it induces the B cell, plasma cell, the IgM mainly antibodies are produced. This will remain in the body for 2 to 3 years and the immunity will go down. But as shown in this chart, if it is a T cell dependent, then the helper T cells along with antigen presenting cells, they are going to specifically prime some of the B cells into plasma cells, which will directly produce IgG antibodies, and that is called as an anamnestic response. Also, with the help of T cells, some of the plasma cells, they are going to be converted into memory cells who are then going to survive in the survival niches or in the bone marrow lymph node. So next time, whenever there will be an infection or vaccine, the memory cells will directly get activated. And remember what they are going to produce? They are directly going to produce IgG antibodies. Now, this reaction is called as a germinal center reaction or a follicular reaction in the lymph node. This reaction is very, very important. All the protein antigens, live vaccine, and polysaccharide conjugate vaccines act through these cells. So even if you give a single dose, you are bound to have a germinal center reaction. But if you want a robust germinal center reaction, you will have to give doses 4 to 6 months apart. You will get a very beautiful germinal center reaction. The GMT titers will go ahead, will be on the top, and this immunity is going to last long, what we call as immune persistence. Okay, so I have simplified the thing. Now let us go to our further slides. So as I've said, now if you are given a vaccine, there is going to be a primary immunity or immune wave. It is going to last for 3 to 6 weeks and then it is going to self-terminate. But if you give another vaccine within a very short period, then these two waves are going to compete for the immune response and might be you are not going to get an optimal response. So how to achieve this is better to keep a gap of 4 weeks between two vaccines so that these two waves do not compete with each other or do not overlap with each other. Okay, so as we were speaking, that there are some diseases which are having a very long incubation period. For example, let us say hepatitis B or hepatitis A. So since the incubation period is very long, once you give a vaccine, the antibodies are formed. After some years, the antibodies go down. It might not be detectable also. But if the person is exposed to a disease, these memory cells, they get activated. They give rise to very good immune response, and there is enough time available because the incubation period is very long, and that is why booster is not needed in these diseases. The examples are hepatitis B or hepatitis A. But there are certain diseases which have a very, very short incubation period. For example, meningococcus. Now, you know that meningococcus, the incubation period can be as short as 1 day. So the range is from 1 day to 4 days. For a memory cell to get activated, it still requires 4 to 7 days. So in case of meningococcus, or even let us say there are other examples like H. influenzae, pneumococcus, diphtheria, tetanus, there is not that much time even for the memory cells to get activated. So what we desire is that there should be pre-formed antibodies in the body so that we will be protected at all the times. We don't rely on memory cells. That is why in these diseases, we have to give multiple doses and even multiple boosters also. And there are some diseases and some vaccines like yellow fever vaccine, the titers will remain lifelong. So you don't need to give immunity boosters because you are going to get a lifelong immunity. As we were discussing about the germinal center reaction, you remember if we keep a gap of 4 to 6 weeks, you are going to get a very robust germinal center reaction and you are going to get a very high GMT titers, which are going to result in immune persistence for a prolonged period. So what is the germinal center reaction? What exactly it does? There is IgM to IgG switch, there is affinity maturation, and there is clonal proliferation. This is very, very necessary. Okay, let us come to the vaccines. What are two basic types of vaccine? We know that there are inactivated vaccines and there are live attenuated vaccines. Inactivated vaccines, you know that the route of administration is important. There is very less interference by circulating antibodies, but they require multiple doses and boosters. Immune response is mainly humoral. They are killed vaccines, so they are safe in immunocompromised and they are more heat resistant. But the live attenuated vaccines, the route of administration is not that critical. They can be interfered by the circulating antibodies. At present, it is said that only single live vaccine is enough, but there is an issue of primary vaccine failure. You know that around 10 to 15% do not respond. So most of the time you have to give a second dose just to counter this primary vaccine failure, and that is why a second dose is given. Live vaccines are going to give rise to humoral and T cell immunity. We know that they are live vaccines, so they cannot be given in immunocompromised. Another problem is there is a possibility of reversion of pathogenicity as we have seen with polio, but they're heat sensitive like OPV also. Now there is a question. You can answer this in the chat box. You can write valid or invalid. I'm going to ask you. So a pediatrician has given varicella vaccine intramuscularly to an adolescent. Will this be a valid dose or invalid dose? What is your answer? Is there any need to repeat the dose? Let us see what is the basis. What happens that in case of a killed vaccine, the antigen content is very, very small. We need to optimally utilize this antigen content. So we want a particular subset of lymph nodes to get activated, and that is why the route of administration is very, very crucial. But in live vaccines, what we want is that the antigen should replicate. What we want that the virus should disseminate throughout the body. What we want is that it should activate multiple lymph nodes all over the body. And that is why the route of administration does not matter and it is not crucial. So that is why the answer to our earlier question was, will that dose be considered as a valid or invalid dose? The answer will be, it is a valid dose. Even I am, if the varicella vaccine, or let us say measles vaccine or MMR vaccine or the live hepatitis A vaccine, if all of these are given intramuscularly only, they will be considered as valid. But that doesn't mean that I'm recommending you that it should be given subcutaneously only, but if you give it IM, we will consider it as valid. Now there is another route, intradermal. So there are some vaccines where the antigen content we are using is so small. We want the optimal utilization of the antigen content, and how best to do that is with the help of the dendritic cells. And where are the dendritic cells maximally found? They are found in the dermis, and that is why some vaccines like the rabies intradermal or BCG intradermal, they are given intradermal to make use of these dendritic cells. Another question. There was this class of 100 students from 10th standard, all adolescents. 99 were vaccinated. One child was absent that day. Now the question is, since we have vaccinated 99th, will the 1% remaining be protected against tetanus disease because all others are vaccinated? You can answer this question, yes or no. Now let us understand the principle. What is herd immunity? Herd immunity is the proportion immune in a herd. So those who are protected by vaccine plus those who are protected by natural infection, if you combine this, it will become a herd immunity. What is a herd effect? Herd effect is incidence reduction of a disease amongst non-vaccinated members when a good proportion is vaccinated. So this herd effect is seen only in infections where the humans are the source. Now let us come back to our questions. We are talking about tetanus. So is tetanus spread from humans to humans? Answer is no. How is tetanus spread, we know that it is spread from spores which are there in soil. It is not transmitted from humans to humans, and therefore herd effect is of no use in this situation. So even if that one single person is unvaccinated, he is going to be unprotected. You will have to vaccinate it. Herd effect will not contribute to his protection. Okay. So we have seen about live vaccines. We have seen about killed vaccines. Let us go further. Let us talk about what is a polysaccharide unconjugated vaccine. So this vaccine is B cell vaccine. It is T cell independent. We have seen already in that basic chart. We know how it is going to act. The plasma cells going to produce IgM antibodies only, very short-lived, no immune memory cells, no booster response. The polysaccharide unconjugated vaccine is not going to act on nasopharyngeal carriage or herd immunity. How does conjugate polysaccharide vaccine act? We have seen in the basic chart, we have seen how it acts by the virtue of helper T cells. High IgG antibodies are formed. The quality of antibodies is high. The duration of response is long. It is going to give immune memory. It is going to give booster response. And polysaccharide vaccines, they act on nasopharyngeal carriage and will be helpful for herd effect. So let us say we have given a meningococcal polysaccharide conjugate vaccine. It is going to act on nasopharyngeal carriage, will help in preventing transmission. Similar about pneumococcal vaccine also. Pneumococcal conjugate vaccine will act on nasopharyngeal carriage, will help in preventing the spread, will give a very good herd effect and protection against even those members who are unvaccinated and are from non-vaccinating age group. Now a question. Adolescent had taken 2 doses of hepatitis B, 0 and 1 dose, but he forgot a 6-month dose. So this he had done 5 years back. Now he has come after 5 years for a third dose of vaccine. Now I have 3 options. I'll tell him, no, you have come after so many years, so let us forget about our earlier vaccines. Let us restart the schedule. The second dose option is I'll give him a vaccine and just complete the series. And third is I'll do a HBs antibody test and then decide on future course of action. So what should be the option? The first or second or third? The option is second. You just give the remaining dose of the series and it will act. So how exactly this we have already seen. With the help of T helper cells, memory cells are formed. They survive in the survival niches and the memory cells are quite intact. So even if you give the remaining vaccines late or after many years, these are going to act and you are going to get very good anamnestic response. So even if some adolescents come to you, they have forgotten some dose from a series, there is no need to restart the whole series. You can just complete the remaining vaccine and the series is said to be complete and it is going to give good anamnestic response. You should not worry about that thing. We have talked about kill vaccine. We have talked about live vaccine, polysaccharide vaccine, conjugate vaccines. Are there any other vaccines? Yes. There are protein subunit vaccines like influenza vaccines. There are vaccines which are using virus-like particles like HPV vaccine. We have viral vector vaccines. We all have taken Covishield, which was a chimpanzee adenovirus vector vaccine, nucleic acid vaccine like DNA vaccine, RNA vaccine, and dendritic cell vaccines. So this is a very big chart. I think you cannot see this on an online platform. But to simplify, what is a viral vector vaccine? Now we are using inert, harmless vectors to carry the antigen to the host, and then it is going to act. Simple. So a vector is used just for transport of antigen to the host. That is called as a viral vector vaccine. We know Covishield, which we have used, that was a chimpanzee adenovirus viral vector vaccine. What is a DNA vaccine and RNA vaccine? Now DNA, it encodes the target antigen, is delivered to the human cells with the help of bacterial plasmid. And what is mRNA? It is a small molecule, the messenger RNA, which is given to the cell. It tells the cell what to produce. So what we are doing here, so generally, we give antigens which are produced exogenously to the body. Here, what we desire, that the host cells should produce the antigen. So we are making the cells to work. The cells are going to produce antigen, and then the body is going to mount an immune response to it. So these are called as nucleic acid vaccine. The two main types are DNA or RNA vaccines. RNA vaccines are a little bit unstable. They require very stringent cold storage, sub-zero temperature for storage, and they require lipid nanoparticles also for the protection. DNA vaccines, quite heat stable, safe, and they are good vaccines. The last point is just to mention it is dendritic cells vaccine, which are also called as therapeutic vaccines. So what we do is we take the antigen presenting cells from the host. Then we culture it with some gene encoding. For example, we know the sickle T prostatic cancer vaccine. So these antigen presenting cells, they are cultured with PAP, GM-CSF, and these antigen presenting cells, which were removed from the host cell, are again injected into the host, and they are going to treat cancers like prostatic cancer vaccine. So a very good new technology, and let us hope that some new vaccines also come from that particular technology. So I hope I have covered most of the points of basic vaccinology, and this will help in further our goal of adolescent vaccination. Thank you. Thank you. Over to you, Ganesh Kulkarni, sir.
Thank you, Sagar, for setting up a wonderful context in terms of understanding just the basics of vaccinology. And wonderfully, you explained the rules, how to go ahead and do the vaccination in adolescents. Now, I think after this, we are supposed to go ahead and talk about Tdap, rabies vaccines, but unfortunately, Dr. Chetan sir is not around. He is stuck up in some kind of an emergency. So I think we have an option to proceed to the next lecture, because Chetan will be joining soon. So I think I'm the one who's going to take the next.
I think you can complete your newer vaccines lecture first, then.
We try to finish that, and then by then Chetan sir will join and finish his topic.
Yeah.
Let me share my slides. So are they visible?
Yes, Dr. Ganesh, visible.
Chairperson Dr. Sanjay Shrirampur sir. Sir, are you there?
No, he is not there.
Dr. Himabindu ma'am. Madam is also traveling, so she is also busy. So let's proceed without wasting much time. As we know that we have been understanding about vaccines which are needed in the age group of adolescents. I'm going to talk about certain newer vaccines which are supposed to be important for this particular age group, which are in the phase of launching. They have not yet been launched in our continent, subcontinent, but they definitely have been launched in some other part of this world. There are almost 271 candidate new vaccines which are eagerly waiting to see us and protect us. But that's not our perspective today. Our perspective is to talk about very few vaccines which are important to the adolescent age group. So we'll be talking about dengue vaccine, the meningococcal vaccine, the polyvalent one, which is about to be launched, and the newer PCV20. So do we really need dengue vaccine? We all know that dengue is perhaps the most rapidly, engulfing the world over. It is almost endemic in more than 100 countries across the globe in tropical and subtropical countries. This particular disease is increasing its presence in the adolescent age group, and it is much needed. The vaccine is much needed because of three reasons. There is increased global warming, the rapid urbanization, even the traveling is very much increased for these adolescents, and that's the reason why they have become more vulnerable. Let us try to understand the incidence of dengue in adolescents. This is the crude incidence rate per 1 lakh of population, which shows that between the age group of 9 to 19 years, you could see here, the incidence rate has gone much higher. So that denotes that adolescents are much sufferers because of this dengue illness. And the incidence is perhaps going up for the elder age group. As the age advances, the disease incidence also is going up. And the other thing that you could see from this particular graph is basically of late, this dengue is showing higher incidence. So this is from 9 to 19 years. Now, the second is the seroprevalence of IgG antibodies against dengue virus in different geographic regions of India. And in this, you could see that the seroprevalence across all regions is much higher in the age group of 9 to 17 years, that is around 41%. Second thing that we come to know from this study is basically the male-female, there is an equality of seroprevalence between those two sexes. Then urban area is much more affected than the rural population of Indian geography. So looking at this, the southern part of our country shows the highest incidence, whereas the least incidence is in the northeastern part of our country. So that means adolescents are definitely suffering from this particular disease. And that's the reason why we need vaccine to cover this age group, which is the only vaccine, dengue vaccine in clinical usage right now. So if you ask me, there was one particular vaccine which was launched, but I would say that that was a very unsuccessful kind of a launch. Dengvaxia, we all know, was launched by Sanofi, but there were problems. There were problems. The biggest problem was the ADE, that is antibody dependent enhancement. And because of that, this vaccine particularly was taken aback. Now, what the newer vaccine, which is there, which is right now is about to be launched, is TAK003, that is Qdenga from Takeda. Now, what this vaccine is, this particular vaccine is a live attenuated chimeric tetravalent recombinant vaccine. The beauty of chimerization here is the backbone is dengue, whereas in Dengvaxia, the backbone was yellow fever. Now here what they have done is they have changed the backbone. They have kept dengue as a backbone, dengue 2 as a backbone. And that's how they could mitigate the risk of AD here. Here the DEN2 virus is used, so lesser number of non-neutralizing antibodies were produced. And because the lesser number of neutralizing antibodies, the risk of AD was mitigated. Now, this particular vaccine had shown wonderful antibody response in across all 4 serotypes. There was quite a bit of observation which was made that the efficacy was really good against 1 and 2, but it wasn't as good as in 3 and 4. Regardless of previous dengue exposure, this vaccine could be given, which was unlike the previous one, Dengvaxia. There was a need of pre-vaccine testing, sero testing was necessary. But here in this particular vaccine, pre-vaccination sero testing is not required. This is given in 2 dosages, 3 months apart, subcutaneously. Let's try to understand the structure of TAK003. This is actually a biotechnological marvel, I would say. Takeda was very crucial in doing this particular engineering. There were a few challenges. Now, the first challenge was ADE, like which was there in case of Dengvaxia. The second challenge was here to generate sero coverage rate against all 4 serotypes. Then the third was the exact level of attenuation. If there would have been a under attenuation, probably the clinical disease would set up. If there would have been an over attenuation, probably that would not cause a greater sero coverage rates. So exact balancing of attenuation was required, and all these 3 things Takeda could achieve it. Now look at the exact structure of this particular vaccine. If you see that this is a dengue genomic sequence, on this dengue genomic sequence, on this 5 UTR side, you see these 3 structural proteins, that is C, premembrane, and envelope proteins, which encode the genes. On the 3 UTR side, you see this NS1 to NS5. These are non-structural proteins, which are very well framed on this ORF frame. Now, this is the this genomic sequence of dengue 2 has been taken. Looking at this DEN2, what was done was they kind of incorporated a chimeric structure. They made it a point to create similar 3 structures of DEN2, but they replaced this premembrane and envelope protein, which encoded the genes, from corresponding same premembrane and envelope proteins of DEN1, DEN3, and DEN4. So the backbone here, the core structure here is the DEN2 virus, and around it, there are 3 more components, and these 3 components come from the DEN1, DEN3, and DEN4. That's how what they have done is they mitigated the risk of ADE. Now, these NS1 to NS5, which are there in the in this vaccine component, they definitely would help to give us cross protection. So NS1, anti-NS1 antibodies of DEN2 would give you cross protection against the other 3 serotypes. And that's how the risk of ADE was mitigated. And then that could be a well reason for giving this vaccine to all those babies who previously were not sero tested. So that's how they created this wonderful structure. and they could achieve a wonderful serotype coverage against all serotypes, the efficacy against all serotypes. Now, let us try to understand what is the exact efficacy of Qdenga. This TAC-003 efficacy against symptomatic dengue at 12 months. Now, what was done was a wonderful long-term trial called as TIDES, that is tetravalent immunization against dengue efficacy studies, which is actually a pivotal study, which is a long-term study with a very good cohort of almost 20,099, out of which almost 72% were seropositive and 28% were seronegative. Now, in this trial, what was done was the primary endpoint, secondary endpoint, and tertiary endpoints were decided. Now, the primary endpoint decided about the viral efficacy, the vaccine efficacy against virologically confirmed dengue. And the secondary endpoints were at 18 months, which was actually the vaccine efficacy against the hospitalized virologically confirmed dengue. Let us see what are the efficacies. So overall efficacy against virologically confirmed dengue was almost about 80%, 80.2%. Seropositive was 82.2%, whereas seronegative was 74.9%. This was at the end of 12 months after the second dose, 30 days after the second dose, till 12 months. Now, the secondary endpoint, that is vaccine efficacy against the virologically confirmed disease with hospitalization, the overall efficacy against seropositive was 94.4%, and against seronegative was 97.2%. So overall, it was about 90% of the efficacy, which is said to be a wonderful efficacy. Now, this was again a region specific. Asia Pacific, the vaccine efficacy was 79.5%, whereas in the Latin America, it was 84.3%. Now, this was the long-term, the secondary endpoints or the exploratory endpoints where you could see the vaccine efficacy age-wise. Between 4 to 5 years, it was 72.8%. 6 to 11 years, it was 80.7%. And 12 to 16 years, it was 83.3%. So overall, this vaccine produced a wonderful efficacy of around 80% against virologically confirmed. And for the severe dengue, it was much more than that. So that was 90.4%. So this was for 1 year and 18 months of efficacy duration. Now, the long-term duration, like overall efficacy against at the end of 4.5 years, at the end of 4.5 years, the overall efficacy was 61.2% against virologically confirmed, whereas against the severe dengue, the hospitalized dengue was 84.1%, and seropositive was 64 as compared to 85%, seronegative was 53 as compared to the 79.3%. And another marvel of this study, pivotal study, was they could evaluate the efficacy against each different serotypes. So the efficacy overall was 64.2% against seropositive and 53.5% against seronegative. But against DEN1 and DEN2, it was good, 56.1 and 80.4%. Obviously, the DEN2 was a backbone, so the efficacy was much higher for DEN2. But the efficacy against seropositive, against DEN3 and DEN4 was 50-70, but the seronegative DEN3 and DEN4 did not show that much of efficacy. It was almost had gone into a negative efficacy kind of thing, which was something to worry about this particular vaccine. Perhaps this is the only drawback that I would say. But the explanation given by the company was that the cohort did not include much number of DEN3 and DEN4 cases. So statistically, it wasn't significant. Now, let us try to understand what are the drawbacks. As I said, it has a wonderful efficacy against DEN1 and DEN2, but it has a moderate and short-lasting efficacy against DEN3 and inestimable efficacy against DEN4. So for DEN4, it is still, I still have a doubt unless and until we have another study with a good cohort, which has good number of DEN4 cases taken into. So Qdenga has a lower and waning efficacy in seronegative individuals with a potential risk of negative efficacy against DEN3 and DEN4 in seronegative individuals at 4.5 years. So this risk is not statistically significant, as I said just now. So what does WHO says? The WHO recommends this particular vaccine. Yes, WHO says that this particular vaccine, TAC-003, could be brought into a routine immunization program for the age group between 6 to 16 years in geographical locations where there is high transmission intensity of dengue, like high prevalence countries or the regions where we can definitely get this vaccine between the age group of 6 to 16 years. Now, the zero prevalence, now, how do we define high prevalence region? Is basically the region where zero prevalence rate is at 9 years is more than 60%, and the mean age of peak dengue associated hospitalization is below 16 years, is below 16 years. These are the two criteria to call certain area as a high prevalence area or high transmission intensity areas. So this vaccine should optimally be initiated about 1 to 2 years prior to the age-specific peak incidence. So if it is 6 to 16 years, we all very well can initiate this vaccination for 4 years onwards. As I said, it is a 2-dose schedule with a minimum interval of 3 months between 2 dosages, has to be given subcutaneously. No data as of now to support booster dosages. Now, there is one more wonderful vaccine coming for against dengue. This is Butantan DV, which is a tetravalent vaccine. It is again a live attenuated recombinant tetravalent vaccine. This has actually been developed by a Butantan Institute in Brazil. With the brain behind it is US National Institute of Health, that is NIH. Now, this NIH has given this SID strain to this particular company, the Butantan Institute, which has developed this vaccine. Now, this is now a large-scale phase 3 trial, which was conducted in Brazil and published in the New England Journal, has said that overall efficacy was 79.6% against symptomatic, virally confirmed dengue over 2 years. So efficacy by serostatus against seronegative was 73.6%, against seropositive was 89.2%. Efficacy by serotypes showed 89.5% against DEN1, 69.62% against DEN2, and DEN3, DEN4 also again here could not be assessed during this period because those serotypes were not into circulation while this study was being done. So almost if you compare head on head, these two vaccines probably have the same drawbacks. But having said that, let us hope for some detailed clinical trials to be done on this. Now, looking at the same seed, that was the strain that was given from NIH to the Brazil, Indian two giants make in India like Panacea is coming up with the same seed strain that is known as dengue all. And the second is basically Tetravax, which is Tetravax DV, that is TA003, which is being produced by Serum Institute of India. So we are really looking forward for these 3-4 dengue vaccines, which will, be wonderfully effective against dengue in this age group of adolescents. So are vaccines the only answer to prevent all cases of dengue? Definitely not, because it has to be a multi-pronged approach needed to control spread of dengue with preventive measures like vector control, proper case management, community education, community engagement, vaccination. So when we incorporate all these things put together, that's perhaps the victory over dengue spread. Now, it's not only against dengue. Vector control is going to help you against other viruses as well, like yellow fever, chikungunya, Zika, because same vectors transmit these other infections as well. That's in preventable diseases as well. So it is a multi-pronged approach to control dengue spread. This was all about dengue. Now, another wonderful vaccine which is coming up is polyvalent meningococcal vaccine. As of now, we know that Men A is available in certain part of this world, the African belt. Men B is available in European market. India has ACWY. And what we have seen over a period of time is that European countries or US, the prevalent serotype serogroup there is B, whereas African belt was prevalent with serogroup A, which after initiation of main A vaccine there, it has slightly been changing to W and Y, whereas the even American market is the serogroups are changing after initiation of the ACWY and B vaccine there. But what we understand that India, Indian subcontinent, the most prevalent strain is serogroup A. So that's how now we see that these adolescents are traveling to Western countries for the higher education, and they do not really have received this particular vaccine, which has B predominant, because they are going to those countries where B is dominant. So now what is more important is to have a polyvalent vaccine where we have all these serotypes put together. And that's how there are these two vaccines which have come up, this Penbria and Penmen-V, which is there in the European market, which is for the age group between 10 to 25 years, which is actually a combination of Men-B with main ACWY. So this is a polyvalent vaccine with A, B, C, W, and Y. And probably we are really looking forward to it, this particular vaccine, because even the death, the morbidity and mortality is very high when someone has this meningococcal disease. The invasive meningococcal disease kills almost 250,000 youngsters every year globally. So we need to take care of those adolescents. Now coming to another wonderful vaccine, that is vaccine PCV, the pneumococcal conjugate vaccine. We all by now have been understood about the 7 serotype, the 10 serotype vaccines, the 13 serotype pack vaccines. Now the latest is this PCV20, that is Prevnar 20, coming from Pfizer's. Now this is yet to be launched in India. The studies are underway, the phase 3 trials are underway. But this is launched in European market, the American market. CDC has already given a go ahead. What extra serotypes that this PCV20 has over PCV13 is 22F, 33F, 8, 10A, 11A, 12F, and 18C. So these are different serotypes in addition to that. So we are almost kind of reaching to the polysaccharide vaccine valency, that's 23. So we really are looking forward. In US, it is recommended for children below 5 years and the adult age group. PCV13 serotypes accounted for almost 21% of IPD. Additional serotypes included in PCV20 but not in PCV13 almost contribute to extra 32% of IPD. So in children between 5 to 18 years, IPD caused by PCV13 serotype was 34%, whereas IPD caused by PCV20, which is non-PCV13 serotypes, is additional 29%. So that's how this particular vaccine, we all are looking forward to it. Now, the another vaccine which is almost launched in India, this is hepatitis E vaccine, which is HEVRIVAC vaccine, which is again a first recombinant vaccine against hepatitis E virus, which was launched by URIHK Pharmaceuticals, developed in partnership with Inovax. This is indicated only for high-risk adolescents from 18 age group onwards till 65. Those persons who have chronic liver disease, who have altered immune status, and those women who are of childbearing age. The administration is 0.5 ml intramuscular injection in the deltoid region. Composition is 30 micrograms of purified recombinant HEV239 protein, which is expressed in E. coli adjuvanted aluminum hydroxide. The schedule is, there's a 3-dose schedule, which is 0, 1, and 6. So this particular vaccine is almost been launched in India and probably would be launched globally world over. So these were the newer vaccines having much importance for the age group adolescents. So we have understood about dengue, we have understood about pneumococcal 20, we have understood about hepatitis E virus vaccine and the polyvalent meningococcal vaccines. Thank you so much. So I hope I must call Dr. Chetan sir. Yeah.
Dr. Kasi sir has to say something. Sir, please.
No, I think it's a very comprehensive presentation he has made. And hepatitis E is going to be only for above 18 years. It's not licensed for use below that. The second thing is PCV20 also presently is licensed only above 18 years in India. And according to information that the company has given, it will be available for pediatric usage only after August next year. But when it becomes available for pediatric use, like USA, I think it may replace the use of PCV13. Of course, there's going to be a lot of cost difference between PCV13 and PCV20. As far as the dengue vaccine is concerned, there are still some ambiguities about the vaccine. The main factor is, of course, safety is not an issue because at least in the phase 3 studies, there have been no signals regarding any ADE at all. The issue is in seronegatives, by the end of 4.5 years, protective efficacy against serotype 3 is almost gone. Against serotype 4, we really do not know whether it works because in the study areas, there was practically no serotype 4 at all. So they are doing now post-marketing surveillance in areas where, serotype 4 is prevalent to find out what its efficacy is against serotype 4. All in all, it's a tremendous improvement over Dengvaxia. Of course, now there is one more vaccine coming in called the Buchanan vaccine, which you just mentioned. The advantage of Buchanan vaccine, it's a single dose. No, it's not even a 2 dose like dengue. It's a single dose, and in whatever the phase 3 studies, it has shown efficacy, very good efficacy, but they have only about 2 years follow up. And again, similar to this Takeda vaccine, we do not know whether Buchanan vaccine also will work against serotype 4, because again, it was done in the same areas where serotype were not present. So a lot of ifs and buts. The whole question is that how relevant is it for India? If you see the seroprevalence study done by Munnerekar, which was published in 2022, see, in southern part of India and western part of India, serotype 3 and 4 are probably more prevalent than serotype 2 and 1. So in this situation, what is the efficacy going to be? These are things which we will know only after the vaccine is used. I think someone asked a question about what is ADE. I think this was asked by Dr. Kailash. See, basically, antibody-dependent enhancement is a process whereby antibodies facilitate the entry of the virus into the antigen-presenting cells. You see, an antibody should coat the entire microorganisms, virus in this case, and the engulfed organism enters the antigen-presenting cells and it is destroyed. But when you have either suboptimal levels of antibodies or you have non-neutralizing antibodies, you see the entire virus virion is not covered. But still attachment to the antigen presenting cells takes place. The whole thing gets internalized. Within the cell, there are mechanisms which, increase, rather decrease the cytokines which are going to kill the virus. So what happens? Paradoxically, the viral load increases and you get enhanced disease. This basically is ADE in short. In short. I think that's it. Anyway, it was a good presentation. I think Dr. Ganesh, I think Chetan is very busy with Dandiyaras. I don't think he will come now. I don't think anyone else is ready. We can probably wind up today. Tomorrow we have 3 hours plus, since today about half an hour went off for the inauguration. We can finish off the remaining 5 modules tomorrow also.
Yes, sir. Yes.
Okay,
Yes.
Dr. Bansal sir, then we can finish tomorrow then. I don't think anyone ready to make the presentation today. Is it okay, sir?
Yeah, I also agree with that, sir. Dr. Ganesh, wonderful presentation.
Thank you, sir. Thank you so much.
Especially your data on dengue was very nice.
So the backbone here, this is a chimeric presentation where the backbone is Dr. Kasi sir always giving us the core
Kasi
stuff.
sir is backbone of entire team.
We almost everybody here is non-neutralizing antibodies, where the only neutralizing antibodies is Dr. Kasi sir.
So true, so true. ये एडी सर बहुत सबसे ज्यादा कोविड के समय चला ना, जब उसमें
Yes.
आया
बरोबर है, कोविड में तो काफी हो गया था एडीए का.
बहुत.
Sir, is this phenomena for all particular viruses or for few particular? No, even COVID had this AD, even the dengue has this AD, but it's not seen in others like influenza and
It
others.
will happen in viruses which have multiple serotypes, not in those who have a single serotype.
But this mechanism is even with RSV also. And that is
Yes.
why RSV vaccine cannot be given in infant. That is the basic
That
reason.
probably is the theoretical possibility of having AD.
The problem with RSV was they used a killed vaccine, and in the phase 3 study, enhanced respiratory disease, almost I think some 4 children died. And then since then, some of pediatric RSV vaccines have been kept on the backbench. No vaccine is even entered phase 3 study also.
They are afraid of bringing it.
Yes. In fact, maternal vaccination and monoclonal antibodies are doing a great job. I think recently USA has, you have got the publication in that MMWR about RSV.
RSV licensing.
Has shown over 70% protective efficacy till the first 6 months, which is excellent.
Huh.
And this AD, I would like to add
the
one more
age,
thing.
Pardon,
age of
Sagar, yeah, please.
Yeah, so in AD, it is producing direct antibodies and cross-reactive antibodies. Now, these
Yes.
cross-reactive antibodies, they remain for 2 years and 3 years. But when at that particular time, when these cross-reactive antibodies go to their lowest level, it is at that time that AD occurs and then abnormal response.
Yes.
Surprisingly, this occurs only with the second, but the third and the fourth infection are very, very mild. And that is why all these principles of vaccination are there.
Right.
The same thing happened with RSV because RSV is also a bivalent because it has a 2 component. And that's the reason AD do occur with RSV vaccine.
Ganesh Kulkarni sir, if there are any specific questions in the chat box, you can take it. Otherwise, then we can wrap it.
I don't think there are anything more.
There's one question on typhoid.
Dr. Manglik Arun Kumar has asked, is the data of PCV13 covering only 21% for IPV? See, here it is following extensive use of PCV13. They found that of the remaining IPDs, 13% was still PCV13 strains. And amongst these, it was type 1, 19A, and 6A, which were the main breakthrough strains. That is what this 21% is. Okay. And when you take the data and see how much additional protection PCV20 is going to give over PCV13, that is around 53%.
Kasi sir, as you said that after PCV20 will come, PCV13 will go out. So after PCV20 will come, I think PPSV23 will also go out.
And now actually GSK is working on a 24-valent conjugate vaccine, which is based on an entirely new platform called multiple antigen presentation syndrome, where the conjugating protein is one of the conserved proteins of the pneumococcus. And that is expected to give serotype, protection which is going to be across serotypes. Probably we may stop at that.
At that point.
Yeah.
But at today's point, when PCV20 has come, in adults and elderly, we say that after giving PCV20, there is no need for
PPSV23 is gone. No one, there is no recommendation for PPSV23 in those who have received PCV20.
So my question is specifically, let us say there is an adolescent of 20 years, a case of splenectomy, PCV20 is allowed. If I have given PCV20 to this adolescent with splenectomy, do I need to give PPSV23 or can I skip?
The high risk, I am not. I'll have to check it up. I don't know. I'll have to. Theoretically, no.
As per CDC, they recommend those who have taken 15 and above valent PCV. There is no recommendation of polysaccharide 23.
Yeah, for PCV 15 you got to give. For 20,
15 and above. 15 and above.
20 and
But below
15 you have to give.
15 you have to give more than 15. More than 15 because PCV 20 there is no need of polysaccharide.
Now PCV 21 is an adult specific PCV. It is not recommended for children because almost 7 serotypes which are common in children have been removed. So that's only for adults.
Yes.
The more 21 valent. So
it was said,
so I think almost all
types are being added, but the carrier proteins are also increasing in the concentration. Is it not causing the bystander inhibition now?
Yeah. See, that is the trouble. You just cannot go on increasing because there is interference between the different serotypes. And the antibody titers of the common serotype start reducing. In fact, if you see PCV13 versus PCV7, with PCV13, the antibody titers are lower than with PCV7 for the common serotypes. So you cannot go on increasing. Second is this carrier-induced epitope suppression. When you are using CRM 197, any other vaccine containing diphtheria toxoid, there is an interaction. So you have to, now they're looking at adjuvants or carrier proteins, which are not contained in any of the other childhood vaccines. And that's why for this GSK vaccine, they're using the conserved protein of the pneumococcus itself.
If we increase the carrier proteins, even the antigen content also increases. So,
Yes.
1 microgram it goes to 2, from 2 it goes to 4. So even the antigen content in all these vaccines have increased because of extra serotypes.
Right. I think Ganesh,
Yes, sir.
if we are done, we can close, sir.
I thank Dr. CP sir for giving his precious time and being with us here today. Thank you, sir, for all your blessings and your guidance throughout this preparation of this particular module. And it's hats off to you for really, at this age to still take
I am
control of.
so grateful to you all that you agreed on my just one call and participated so actively in this module. Entire chapter is grateful to you for that.
All of the writers here and all of the contributors here have done a wonderful.
A closing remark from me, please.
Was,
I
convener
am
of-
Dr. Indrashekhar Rao. I am silently sitting in the last bench and
No,
listening to the
You will
performance.
be on the last bench. You are always there in front of our eyes.
No, Ganesh, I am in the last bench listening. Thank for the expertise of Kasi guiding us, updated expertise on the vaccine. And all the participants have done with so much enthusiasm. And we really show gratitude to him for that. And this module is going to be the very latest and updated module. And actually, Himabindu has been requesting this thought about a year back. It has taken existence and life, and it will definitely going to be a good learning for all the pediatricians, not only the adolescent chapter. Thank you, Dr. Kasi again.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, Sharma sir. Thank you, everyone.
So tomorrow 2
Thank
p.m.
you, sir. Thank you.
Thank you, sir.
Welcome back.
Again.
Yes.
Yeah, madam.
But actually, because of the festival season, so I think many of the people some of them couldn't join. Tomorrow we expect a bigger gathering, and Dr. Chetan Trivedi will also join tomorrow. So thank you for all the delegates who have participated today, and please, we look forward for seeing you tomorrow at 2:00 afternoon. Thank you,
Thank
Kasi sir.
you.
Thank you all the
sir.
speakers.
Thank you, ma'am. Thank you, everybody.
Thank you.
Thank you so much. Happy festive season to you all. Good night.
Thank you.
Good night.
Good night, sir.
Navratri.
Happy Navratri. Happy Navratri.